Number 4 from the C2 paper Jan 2011, integration. The topic is integration, but before that let me show you what the formulas that you're going to use and which formulas they are going to give you in the formula booklet. So the first 3 formulas, you have to know them. They will only give you the trapezium rule in the formula booklet, and we will discuss the trapezium rule in coming videos. Let's talk about the first 3 formulas. So in order for us to find the definite integral, we have to use this formula where you integrate. So as if you're finding the indefinite integral, you integrate f prime of x dx, but instead of writing the answer with a plus constant in the end, here you're going to remove the constant and you're going to find an answer. The answer is due to the bounds that you have here, the lower bound and the upper bound. And when you have the lower bound and the upper bound and they are numbers, so you actually replace the upper bound f of b and you subtract the lower bound f of a from it. And I'm going to explain in the exercise exactly how we do it. Now the area beneath the curve with equation y equals f of x. So this is y equals f of x, the curve, and between the lines x equals a, so this is the line which is parallel to the y-axis, so it has an equation x equals a, which is the x-intercept, and x equals b, which is the also a line which is parallel to the y-axis and intercepting the x-axis at b. The area that you're going to find is this one. So they will give you the boundaries of the area, and in order to find this area you have to integrate to use the definite integral in order for you to find the area. The area between a line of equation y1 and a curve of equation y2 is given by. So also you find the area by integrating, but this time you have to subtract the upper. So this is the upper minus the lower. Okay, this is why they wrote y1 minus y2 dx. So you always use, whenever you want to find the area between 2 lines or 2 curves, you always use the formula which says the upper minus the lower and integrate it, and then you will find the area between these 2 curve. It depends, is it a curve and a line or a curve and a curve, or so on. Now the trapezium rule, we're going to discuss it in coming videos. So let us start to apply. January 2011, number 4, this is the figure that you have. And let's read the question. Figure 1 shows a sketch of part of the curve C with equation y equals x plus 1 times x minus 5. The curve crosses the x-axis at the points A and B. Write down the coordinates of A and B. In order to find the coordinates of A and B, we need to find the solution between the y, or the C here, the curve, and the x-axis. What do we mean by that? So you have A situated on the x-axis and B situated on the x-axis, so the ordinate of these 2 points, or the y of these 2 points, is 0. So when the y is 0, then you can find the values of the x values of A and B. So they already gave you the equation of the curve factored. Therefore, it's very easy to find the value of the x here and the value of the x here. So you start with x plus 1 equals 0. Therefore, x is equal to minus 1. And x minus 5 is 0. Therefore, x is equal to 5. And definitely A is the one that has minus 1 as an x, and B has the 5 or 5 for its x. So we wrote, so you have to write A and the coordinates of B in this manner. The finite region R, shown shaded in the figure, is bounded by C and the x-axis. Use integration to find the area of R. So here you have to use integration, and it's the basic formula that you have to use. The only thing that you have to pay attention to is the bounds. So the bounds are minus 1 and 5. And you have to expand y, because you cannot integrate having y factored like this. So expanding y, you're going to get y equals x squared minus 4x minus 5. So you multiply x times x is x squared, and then plus 1 times minus 5 is minus 5, and then you multiply out times out is minus 5x, n times n is 1x, subtract or add these two together, you get minus 4x. Once you expand, now you can integrate it, having the bounds to be minus 1 and 5, which is done here. Now you integrate. Remember that the formula of integration goes like this. You add 1 to the exponent and you divide by the new exponent. So you add 1 to the exponent and you divide by the new exponent, and here it's x to the 0, so you add 1 and divide by 1. And then you need to plug in the bounds, the minus 1 and the 5. So you start by plugging in the 5 and then minus plugging in the 1. This is the formula, f of a minus f of b minus f of a, where this is b and this is a. So here you're just applying the formula. So until now we have used the integration here. In order to go to this step, we just integrated, and then we just replaced the bounds in the second step. Replaced the bounds, and from now on, from here onwards, it's algebra. So what exactly do you have to know? You have to know how to integrate and how to replace properly, and then the rest is algebra, and mainly you use your calculator in order for you to find the answer, which is minus 36. Now, the question here is this: how can an area be a minus 36? You have to be careful that when the area is negative, you have to take the absolute value of the area and write it without a sign, which is 36. Now, why did the area become here, or the result here is negative? Because you have the area that you're working or that you're finding under the x-axis to the negative side. So it's under the x-axis, not above the x-axis, because the results here are negative, so they are minus, and the numbers here are positive. Therefore, when it's under the x-axis, you're going definitely to have a negative area. But since the area is a positive number, or it's a magnitude of the area is a magnitude, therefore you write it in absolute value and you write the actual number that you found without a unit.